Hello. Welcome to the speculative biology series I have made called Project Protolis. I hope you like it. In this episode, Episode 1, we will be talking about the planet and its system. It all starts 5.42385 billion years ago. A large O-type star was at the end of its short lifespan and it was about to explode. With a bang it went boom. A giant cloud of dust and rock began expanding into a length of 35 light-years until it stopped. There is a black hole inside of this big mess, but we aren't here to talk about that. We are here for the star. 5.14821 billion years ago, the star was almost done forming. There was another large clump of mass that was also forming, but it wasn't able to get that big. This is where the entire system began. The star would be fully formed about now. The gas giants would start form in, and the gas giants would have started to form. There would be about 5 of them that form. This is Sinezalina. It is the smallest gas giant in the system, not smallest planet. It has a greenish-blue tint and a strong magnetic field. It was the last gas giants to form in the system. That's why it has such a small size compared to the others. Its density would be 10.22 kilograms per cubic meter. Its radii would be 20.14 Earths. Its axial tilt would be 62 degrees, and its mass would be 15.19 Earths. This is Boicea. It is the second smallest gas giant in the system. It has a large storm raging on its surface with wind speeds up to 780 kilometers per hour. This makes it so the Great Storm is at a temperature similar to Earth's during the Ice Age. Its density is 10.57 kilograms per cubic meter. Its radii is 21.18 Earths. Its axial tilt is 172 and its mass is 18.21 Earths. This is Jupiter. It is the second, or third biggest gas giant if you count the brown dwarf. It is a large gas giant that has large rings similar to Saturn's. They formed when the gas giant ripped a dwarf planet apart. This gas giant's density is 3.87 Earths, its radii is 31.5 Earths, its axial tilt is 2, and its mass is 30.28 Earths. This is Vita. It is the first biggest gas giant by mass in the system. It has a squished egg-like shape because of its fast rotation period. One day on this planet would be about 3.3 hours. That's pretty fast. Its density is about 13.46 Earths, its radii is 25.6 Earths, its mass is 85.6 Earths, and its axial tilt is 180 degrees. This is Micro. It is a brown dwarf and the second star in the system. It is in a binary orbit with the K5V-type star. All of them orbit. It has a mass of 8,213 Earths, a radii of 8,213 Earths, an axial tilt of 43 degrees, a density of 1 Earth, and it produces 1025 watts. This is the star of the Pacro system. It is a K3V-type star that produces lots of red and green light. Its mass is 229,734.74 Earths. Its radii is 229,732.74 Earths. Its density is 1 solar mass, and its habitable zone is 0.6 astronomical units. Zaporti is a Mercury-like planet right on the beginning of the system. It is tidally locked and has a molten rock part in front of it. It has a twilight zone near the cold side, but it sadly is dry. Its radii is 0.408 Earths. Its mass is 0.089 Earths. Its axial tilt is 23 degrees, and its density is 5.45 kilograms per cubic meter. This is Merge. It was liquid water near the poles. It has a large hot area on the equator which separates the water. Life may be able to evolve here, but we're not going to focus on it right now. Its mass is 0.87 Earths, its radii is 0.87 Earths, its density is 1 Earth, and its axial tilt is 31.4 degrees. This is Protolis. We will be focusing this account on this planet. It is an Earth-like planet, but it is colder and slightly more massive. It has 3 moons, 2 major and 1 minor. It also has rings from a collision. Its temperature is 9 Celsius. Its mass is 1.15 Earths. Its radii is 1.15 Earths. Its density is 1 Earth. Its axial tilt is 38.3 degrees. Its year is 140 Earth days, and its day is 15 hours. This is the atmospheric composition of Protolis. It's made of 68% nitrogen, 20% oxygen, 7% carbon dioxide, 2% methane, 0.9% hydrogen sulfide, and 0.1% trace gases. The surface of protolis would be made of 50% oxygen, 10% silicon, 10% copper, 8% magnesium, 20% iron, 1% nickel, and 0.9% random other metals. The trace gases in the atmosphere would contain 50% water vapor, 40% helium, 5% neon, and 5% various oxides of nitrogen. Because of the larger axial tilt, seasons would be more extreme, with longer winters and summers that were more cold/hot, and spring and fall would almost be the same. These are the moons, excluding the minor one because it doesn't contribute much. Dal is the biggest one with 1.50 moon masses and 1.50 moon radii, and Jagundal being the smaller one with 0.65 moon masses and 0.66 moon radii. Now let's see how the continents will break apart and rejoin over time. Protolis would be more active than Earth, making earthquakes and volcanoes more common. This will help life evolve from the volcanoes erupting under the ocean and islands form. This is what the surface of Protolis would look like. It would have eclipses from the brown dwarf almost every day and rings that would shine at night. This is the system of Protolis. Well, that's it for this episode. I hope you come back for episode 2 of Project Protolis, where we make life.